welcome to this tutorial today. Today we're looking at how to do simplified voltage drop, which is a method from AS3000. For our circuit today we have a consumer main here which has a 2% voltage drop. It's a three-phase consumer main. Here we have a final sub-circuit which is single phase. It's 51 meters long. It has a 16 amp circuit breaker type C for the protection. It's a V90 copper TPS cable. And what we're trying to do today is to determine the minimum cable size for the final sub-circuit based on voltage drop, with a 2% voltage drop on the consumer main. So to do this, you'll need a calculator. You'll also need your Australian standard AS3000, and specifically we'll be using table C7 today to try and solve this problem. Okay, so the first thing we have to do is we have to determine how much voltage drop we have remaining for this final sub-circuit. So you'd be aware from AS3000 that we have a maximum voltage drop from the point of supply to the furthest point on any final sub-circuit of 5%. So that means if we have a maximum of 5% available, then we've already dropped 2% on this consumer main. Now they haven't given us any information about the consumer main. We don't have to calculate it. They're simply stating that we've lost 2%, which makes this question significantly easier. So that means we have 3% remaining. It's a simple calculation of 5%, so remaining voltage drop is 5% minus the 2% on the consumer main, which leaves us with 3%, which is a pretty typical value for a final sub-circuit, an intelligent value. If the percentage voltage drop is much smaller than 3% for a typical circuit, you're going to be having oversized final sub-circuit cables. Okay, so how do we actually solve this? Well, what we need to do first of all is work out the amp meters for the final sub-circuit. So the way that we do that is we simply go amp meters. So this is the final sub-circuit amp meters, and all we do is we multiply the length of the circuit by the maximum demand. In this case we haven't been supplied with the value of current for the actual load, so we'll be using the 16 amps on the breaker. So the amp meters is simply 51 times 16. Now, there's a little bit of a trick you have to be careful of. Some circuits, if they have a distributed load, AS3000 clause 3.6 has a exception where you are allowed to use 50% of the load rating, or 50% of the maximum demand. So in that case, if this were a final sub-circuit with socket outlets or lighting points where the load is distributed along the length of the circuit, not just simply at the end, which is the case here, then you're allowed to use, we could use 8 amps for our calculation, which effectively gives you double the available voltage drop, which means the circuits will be more realistically sized. Okay, so 51 times 16, if you needed your calculator to do that, simply go 51 times 16, which gives us 816. So that is the required amp meters for the circuit. Alright, so what we need to do now is we need to work out, because table C7 shows the values of the cable in amp meters per percentage voltage drop, we need to convert the amp meters and the available percentage voltage drop into a value that we can collate with table C7. So the way that we do that is we take the amp meters for the circuit. So to find the amp meters per percentage voltage drop, which is the values from table C7 in AS3000, we need to take the amp meters and divide it by the available percentage voltage drop. So it's a pretty simple calculation. So once again, we have 816 amp meters, which we have to divide by the available voltage drop for this circuit, which, as we worked out earlier, is 3%. So we go 816 amp meters divided by 3, get our trusty calculator out again, and we go 816 divided by 3, which gives us 272 amp meters per percentage voltage drop. And now that value there, we can now go to table C7 on AS3000 and work out what size cable will have a capacity of at least 272 amp meters per percentage voltage drop. And so we'll do that now. Now if you go to table C7 on AS3000, you'll notice that it has two different values besides the cable size. We have single phase and we have three phase. This is a single phase final subcircuit, so therefore we'll be looking at the single phase column, and we'll simply look down that column until we find a cable that has at least a capacity of 272. Now if you have a look on your AS3000 table C7, I'll write the values down here. 1 millimeter squared cable has a capacity of 45 amp meters per percentage voltage drop. So you can see that's too small. 45 amp meters will yield a 1% voltage drop on a 1 mil cable, and we need at least 272, so you can't use a 1 mil cable. 1.5 mil from table C7 has a capacity of 70 amp meters per percentage voltage drop, and you can see also that is too small. 2.5 mil, the next size cable going up, has a capacity of 128 amp meters per percentage voltage drop. Once again, too small. So you can't use a 2.5 mil cable, it will yield more than 3% voltage drop. So we go to the next size cable, which is 4 millimeters squared. It has a capacity of 205. So we're getting closer, but still not there. Now of course, when you're looking this up on table C7, you don't need to write all these out. I'm just simply writing out for the benefit of the video today. You can simply look down the table, find the correct cable size, and you're done. It's quite simple. So 4 mil is getting closer, but still too small. The next cable up is a 6 mil cable. And a 6 millimeter cable has a capacity of 306 amp meters per percentage voltage drop. And you can see that the 6 mil cable is large enough to give us 3% or less in our voltage drop. And so the answer to the question, what is the minimum cable size for the final subcircuit based on voltage drop? And the answer is 6 mil. Now one more thing, we will just finish off this question. It doesn't actually ask us to do this, but we'll do it anyway, and that is we're going to work out the actual voltage drop on that 6 mil cable, because the capacity is greater than the required 272. That means the actual voltage drop will be a little bit less than the 3%. So we'll work out exactly what the voltage drop will be for this 6 mil cable. So to do that, we simply have to work out how much voltage drop we have available, which is 3%. We also know the value of the amp meters per percentage voltage drop for our 6 mil cable. So all we do is we work out our amp meters, the actual amp meters for the circuit. Okay, so the amp meters for the circuit, which we already have, is 816. So we've got 816 amp meters for our circuit. we divide that by the amp meters per percentage voltage drop for the cable, which is 306. So that's your amp meters divided by your amp meters per percentage voltage drop, and you can see that the amp meters cancel and it will leave you with the percentage voltage drop. So we get our calculator out again, we go 816, we divide that by 306, and we get 2.66 repeater. So 2.6, I'm going to round that to 3 significant digits as we do in our electrical trade course. So the percentage voltage drop will be 2.67% on the 6mm cable. And that is how you do simplified voltage drop. Cheers, see you next time.